I'd like to welcome Professor Dorian Garrick from Iowa State and Massey University. Dorian is well known to many of you in the room, and from our point of view, and I know from my chairman's point of view, he's very happy that he's going to be moving back down under later this year, so we'll have his almost undivided attention. Dorian has kindly agreed to talk to us about the Power of New Zealand gene pool, so thank you very much.
Thanks, Graham, and thanks. It's always good to be back in New Zealand and see so many old friends and some of the younger ones as well. And it's always particularly good to be back in New Zealand around the duck shooting time. But if I did have to have a request, it would be next time, can you have the meeting maybe in Southland or somewhere where my daughter seems to be able to get a limit bag of ducks almost every other day. So I was asked to talk a little bit about the power of the New Zealand gene pool and a little bit about data recording in the US. But I actually thought I'd turn it around the other way and talk about the US first and then talk a little bit about New Zealand. So it's easy to look at a bull or to look at an EBV and think about that one particular animal. But when we look at a bull, you might look at a bull and you might be interested in his phenotype. As far as I'm concerned, what's interested in the bull is he's just an envelope of DNA. And it's the DNA from that bull that gets passed on to his offspring, and that's what determines the performance of the next generation, and that's what determines the profitability. So I'm more interested in things from a population perspective. So we might have a pool of selection candidates, and here I'm showing you their phenotypic weaning weight and their phenotypic birth weight, and you'll notice that they are associated. It's not a circle. The ones that have the higher birth weights tend to have the higher weaning weights, and the ones that have the lower birth weights tend to have the lower weaning weights. So there is a correlation between those two things. So what I'm interested in knowing is, in a generation from now, where can I move that cluster of animals? Now, I've only shown it here for two traits, birth weight and weaning weight, but there's actually many more traits than birth weight and weaning weight that we're interested in. We might also be interested in aspects of the maternal ability of the cow, the number of calves she can produce in her lifetime, how much food she eats. So I can't imagine what this thing looks like in 4 dimensions, but you can imagine in 3 dimensions it would be like a cloud of flies or something, right? It's a cluster, a cloud in 3 dimensions or 4 dimensions or more, and we can move it any way we like. So the question you have as a breeder is, which direction do you want to move it? So you could easily move it up and to the right by selecting on either birth weight or weaning weight. Because they're correlated, they're both going to tend to increase together. But if you want to say hold birth weight and increase weaning weight, that's going to be more difficult. But by selection, we can move the cloud any way we want to move it. But some ways that we move it will be more profitable than others, and some ways that we move it will be easier to move than others. So very easy to move to bigger, more difficult to move for bigger for some traits like weaning weight, while we hold other things constant. So we can give lots of lectures, and we have over the years, telling you about how you can do these things, and we promote concepts like economic indexes, where you weight all the traits and have some overall measure of value, and you select on that value proposition. But when you go home or when you go to a bull sale, we never quite know how you make the decisions. So we can only look back retrospectively to see what you've done. So although some people don't believe in breeding values or don't believe in estimated breeding values, if you're going to move that cloud, the only way that cloud moves genetically is because the breeding values of the animals that were chosen as parents were different from average. So whether you have EBVs or not, it's breeding values are the underlying measures of the merit of the animals, and that's what determines whether that cloud shifts. So that's true whether you're doing artificial selection, where you choose who becomes a father and who doesn't, or whether it's natural selection, where the ones that have a higher reproductive rate contribute more to the next generation. Okay, so what we tend to do is like looking backwards at the breeding values of the animals over time, retrospectively, to see how you did your selection, because that tells us something about how you moved the cloud, right? I don't know how you're going to move it this year, because that's going to depend on the bull selection decisions you make. But I can look back here. This happens to be American Hereford Association genetic trends going back to 1980, so that's about the time I graduated as a student at Massey from my ag degree. So this is over my career. This is showing you the breeding values, the estimated breeding values, so it's actually EPDs in pounds, but that's near enough to the EBV in kilograms, for yearling weight and for weaning weight. And of course what we're always looking for when we see these kind of things is how well is it doing compared to what we might theoretically expect. And we're also looking to see if we can see some kind of an inflection. And we'd hope we might see some kind of an inflection that's a result of some good information we educated you about that led you to change your practices. And here, if we look at the Hereford one, we can see that something happened about 1990. And if we look a little bit closer, it turns out that was the time that ultrasound imaging of carcasses of live animals started to be being used. So that meant breeders were able to change the cloud not just by selecting for weaning weight or for yearling weight, but also taking into account something like the IMF or marbling or the meat yield based on the eye muscle area. So the trend for yearling weight went down because they were investing some of their selection pressure to improve the carcass traits. So they changed the direction they were moving that cloud, and presumably that was a change in a good direction. Now, we just heard from the last speaker that Angus has a much bigger impact on the US in current times, both in terms of direct Angus animals, but also their contribution to Limfex and Balancer and Red Angus and Simmental and so on. Here are the corresponding trends for yearling weight and weaning weight in the American Angus Association. And one of the things that always surprises me is how remarkably straight those lines are. So they've been going up very straight right since 1980 again, about the time that I graduated. So if you want me to predict what they're going to look like in 2020 or 2025, I can put a spot out there that will give you a pretty good indication of where it is. And here is the corresponding increase in carcass weight. So not surprising. I told you before that birth weight and weaning weight positively correlated. If you select for one, the other one tends to go up. So when you change birth weight, weaning weight, yearling weight, carcass weight, mature size, all of those things are going to tend to go up together. So in the US, one of the ways that they have improved the profitability of their beef production system is to increase the carcass weight. So over the years, the carcass weights, the weight at which they harvest the animals, have continued to go up. And here I just show you from 2000 up till the most recent data that I had, that they've increased by about 30 kilos. So they're getting up to somewhere around 390 kilos, and they appear to just be continuing to go up. And there's a whole lot of good reasons for that. It dilutes overhead costs. It's exactly the same reason why chickens are harvested at much bigger weights now than they used to be, and pigs are often harvested at bigger rates. And we're going to see more and more of that happening. Lambs are being harvested much more, not at the 13 kilos they were when I was a student, because of that dilutes the cost of transporting and harvesting them and so on. But in New Zealand, we're on a pastoral-based system, and to take them to heavier and heavier weights is often not an economical thing to do. And interestingly, when you look back at New Zealand data for steer harvest weight since 2000, they are unchanged. They're sitting at about 300 kilos. Now that's what Wayne tells me is not the case in Australia. In Australia they have been going up, and they have a view that they should be predicting them up out to 400 kilos, but Australia is doing a lot more feedlotting and has a slightly different economic circumstances than we are. Okay, so genetic change, it's easy to achieve. It's real easy to move the cloud. It's particularly easy to make things bigger. And one of the reasons for that is that the predecessors of most of our livestock and companion animals were much bigger than the domestic versions of them. So the predecessor of Bos Indicus and Bos Taurus, the cattle that we typically run in New Zealand, was the oryx, and the oryx was very, very big. And over the years, has been selected to be smaller and smaller and smaller. Just like the wolf was selected to make dogs, and most dog breeds are much smaller. So it's very, very easy to select back in the other direction because there's a lot of genes there from those ancestral circumstances. So genetic change is easy, particularly to make things big, but it's a little bit more difficult to achieve genetic improvement. So I talked about moving that cloud. You can move that cloud in one direction, and that might make something better, but it might make something else worse. So to get genetic improvement, you've got to have the right balance of the adjustments you make to these traits. And technically, we know the best way to achieve that balance is to do the selection with an index. And an index will properly weight all of the traits. But it's actually not enough to just have an index. You also have to have the EBVs for all the traits that matter to your production system. Okay, so here are the American Angus Association dollar index trends in a way you might not see them very often, but this is on the y-axis there. This is the cost of feeding a cow. So since weaning weights have got bigger and birth weights stayed similar, yearling weight's gone up, mature cow weight, carcass weight all gone up, it takes more feed to feed that bigger cow. Now the other thing that's gone up is the milk production, the weaning weight maternal. There's been selection for that as well. And when you increase the milk production potential of an animal, you also increase the feed requirements even when they're not lactating. So a steer born to a high milk production sire will eat more for maintenance than a steer born to a low milk production dam, even though the steer is obviously not producing milk. So an increase in the mature size of the cow and an increase in the milk production will both lead to an increase in the feed requirements of the cow. So this shows you again back to 1980 compared to the modern Angus. This is the average daughter of an American Angus bull. They are eating something like $130 more feed per year as a result of the selection that has occurred, right? So they've moved the cloud in a way to make them bigger, which has made the cows eat more, and based on the index for predicting the feed requirements of those cows, it's about a $140 increase. So that's an erosion of profit unless you're making more than $130 advance from other traits. So here is the dollar beef index increase. So remember I told you they've been killing them at heavier weights, and so if you select for larger animal size, they will grow faster. You can kill them earlier, you can kill them at heavier weights. They've also been selecting for marbling, which is part of the payment system, and those are all favourable things. And according to the American Angus Association index values for those, an average 2015 steer in terms of its EBVs would earn about $143 more than a 1980 steer. So what you can see is the American Angus Association, and it's true of most of the other associations as well, they have hugely moved the cloud, right? They've done selection to move the cloud, and they've moved the cloud in a way to make them have higher levels of marbling and higher growth rate, which is good. But the thing that they sometimes forget is they have increased the cow weight and increased the cow costs, which is bad. So the net effect on profit depends on the extra costs, the difference between the extra costs and the extra income. Okay, so an average 2015 daughter will eat $130 more feed than an average 1980 daughter, and an average 2015 feedlot offspring will earn $143 more. So I would call that huge genetic change. I wouldn't call that huge genetic improvement. Now you do have to be a little bit careful because the American Angus Association is not very transparent about the way they calculate these indexes. So you can't go to peer-reviewed published journals and find out exactly how these indexes are calculated. Now, I have previously done calculations of the same kind of thing based on EBVs, and my assessment was that for a cow-calf operation, the cows today were maybe worth about $1 per year, the genetic trend, more than they used to be. But based on these two ones, it looks like it's pretty close to zero. That will depend a bit on what the price of feed is. And I just had an email this morning saying that they are predicting, if there's no drought in the US, that corn prices will be down to $3.20 a bushel this year, which will make it much cheaper to feed an animal. So it looks like there's been a lot of selection to improve feedlot performance, but maybe not so much selection to improve performance of the cow-calf operation. Okay, and the other thing that of course is critically important, I only showed you growth and feed requirements, is what happens in reproduction. And sadly, if we ask what's happened in reproduction, I really can't tell you very much. And one of the reasons for that is that until relatively recently, most US beef breed associations have not had total herd reporting. Now, when I started doing beef work in the US back in my PhD days in 1985, I was surprised to see sex ratios where some bulls had 80% or more of their offspring being daughters. And I thought this was very unusual because I thought, you know, an animal was meant to have half of each. Well, it turned out that the breed associations were charging to collect the performance data when you registered the animal, and you didn't have to register them till they were about yearling age. So if the animal turned out to be a cull one you didn't want to register, you never gave them the data. So the consequence of that is, if you look at the history of the pedigree of a particular dam, you can't tell if she calved every year or not, which means we can't tell what the cow reproductive performance was. So most breed associations, not all of them, have made total herd reporting mandatory, but that has not been going for as long as it really needs to get a good idea of the genetic trends in reproduction. So I can't really tell whether reproduction has gone up or stayed the same or got worse. So people often think that the US beef industry is best practice, and I think when I was asked to give the talk, maybe that was the impression that they thought I would talk about, but I would not call it best practice. And it's not just something I would say here because I'm in New Zealand. I've said this numerous times at beef conferences in the US in front of breed associations. There's lots of data on growth, birth, weaning, yearling weight, that make it very easy to move the cloud for growth. There's almost no data on reproductive performance. The American Hereford Association is just releasing a prototype heifer pregnancy and a sustained cow fertility breeding value now, but they should really have had those things 20 or 30 years ago, but they didn't have total herd reporting them. There's some ultrasound data collected, but it tends to be on seed stock animals, and so you don't get the same discrimination in ultrasound measurements that you would on feedlot animals. There's almost no carcass data. So the American Hereford evaluation, where they combine all the US and Hereford and Argentine and Uruguayan animals together, there's about 6 million animals in the pedigree for that evaluation. There's only 6,000 animals with carcass records. And I find that appalling. And one of the reasons is that when an animal goes to a feedlot, one of the first things they often do is they cut out the ear tags and put their own ear tags in. So they break the connection, even though you may have known who they were up until that point. If we go to Ireland, and Ireland was trying to get access for its beef to various other markets, and they introduced electronic ID, every carcass weight of every animal killed in Ireland goes to the performance recording database at ICBF within about 24 hours. and 50% of those animals have sire identified. So they don't need any ultrasound data in Ireland because they've got the real carcass data on every animal that's killed. And we've had electronic ID and NAIT and so on in New Zealand for quite a long time. And I know when I was farming out here at Colleton, when we sent some animals off to the works, we would get back the kill sheet with all the individual data on the ear tags. We need to get a lot more carcass data into the system. And there's almost no disease data. Almost no data of things like pink eye, New Zealand, facial eczema, incredibly important. A lot of people don't want to record those kind of things. They don't record defects. So we find defects all the time in the dairy industry because dairy farmers report them. They don't see it as their fault when a calf has a problem. But it's very rare for a bull breeder to report a defect because they're worried it'll get out that there's a problem in their herd. But after we discover them, we can work backwards and we discover they've been out there in many of these herds for a long time. So best practice, what would best practice look like? To me, best practice for the US would not be measuring 500,000 animals a year for birth, weaning and yearling weight. It would be measuring many less than that for a much more comprehensive range of traits so that you can move the cloud in the appropriate direction at the same time. Okay, so that's Australia. Let's come a little bit closer to home to where was the implication that most Aussies are dishonest. Is that what it was, Wayne? I don't know about that, but this is an honest Australian, Roger Barlow, who back in 1984 said, based on all the literature, there's little justification for selecting for growth rate to improve the efficiency of meat production in maternal breeds under favourable environments. And he said that a major limitation of selection for growth rate was that any increases in gross efficiency among growing stock appear to be more than offset by higher maintenance requirements of breeding females. So it's a little bit unfortunate that the American Angus Association people weren't at that World Congress in 1984 and taken more note of it, because if they had, they might have brought in some of those EPD measurements for those traits a little bit earlier. Now, some of you may know about the Trainee selection experiment. It was started in 1979. They took 220 Angus cows and they selected them for yearling growth. They had an up line they called the high, a low line for down, and a control line. In those days, we didn't know that we could determine genetic trend from EBVs. We thought we had to have control lines. And they got a response of about 2 kilos a year upwards and 2.5 kilos a year downwards. Pretty small selection experiment. And I find it quite remarkable that an experiment run in 1979 with only 85 cows could have had such an amazing impact around the world. But when I go to shows where I'm talking, it's often that they will have some low-line Angus in there. So it also surprised me a little bit that the genetic trend in the low line was actually a bit higher for the decrease, 2.5, than the 2.1 of the increase for the highs. I would have expected the highs to got bigger faster than the lows got lower, but that may have just been a chance effect because they were such a small herd. So a self-replacing herd turning off slaughter progeny at 18 months of age, the high line did return a higher gross margin, but it also consumed more feed than the control line. So that says if you had a certain amount of pasture, just like the situation that Wayne was trying to describe, you'd only have 95 high line cows on the same herd, on the same farm that you could run 100 control line cows. But they would return more than profit, about 15% more, and they were more profitable because they had higher carcass weights at 18 months. So they'd moved the cloud, they were killing them at the same age, so they were heavier when they were killed. And in that selection experiments, the low lines actually had a reduced calving rate, so that helped as well. But the Australians also did some other interesting tests. They used high controlling low lines at medium and low levels of nutrition at Glen Innes, and they showed the high line was more profitable than other lines despite having a higher feed requirement. And the differences again were largely due to different turn-off weights for each line, right? Different harvest weights. But again, remember I showed you since 2000 there's been no change in the harvest weights of steers in New Zealand. It's possible they are a little bit younger, but unfortunately there's no data on that. Now, I can't tell you whether the age of those animals at 300 kilos is less now than it used to be. In Hamilton they did another study at various stocking rates, and they said selection for growth increased productivity. At similar grazing pressure there was no difference between high and control lines. There were only marginal gains in efficiency. And basically their conclusion was that other selection criteria needs to be established to enable the industry to select animals for increased efficiency. So what they're saying is if you want to move the cloud in a way to make it more efficient and more profitable, which is what I would like to think that you want to do, then you've got to record a lot of things other than growth. And growth is an easy thing to select for. You can see it. You hardly need a set of scales. You can select the bigger looking animals and you get a response. But if you really want to make improvement rather than change, you've got to measure all those other traits, particularly the reproductive one and the mature cow information. So you might say, well, that's Australia and they're different, and we know that's true. And that was the US and they're different too, and we know that's true. But New Zealand is, a whole nother place. So I remembered about feed budgets and things that I did when I was a student. So I pulled out one of the books that was on my bookshelf back from those student days. This is a little book that was called the Waterway, and it was a book that described a whole lot of information about how you might run sheep and beef cattle flocks and herds in New Zealand to have good levels of reproductive performance and profitable performance. So this is the suggested live weight for an average New Zealand Angus cow herd back in the time about 1980 when I was a student. And the recommendation was that you would reduce the weight of your cow by about 15% over the winter time. And when she calved in August there, she would be, in that graph, for about 370 kilos post-calving. And then as the spring growth took off, she would put that weight back on again. So we're using the cow, instead of feeding hay like those Australians were doing, Wayne was telling about, you get the cow to carry the energy from one time of the year to another on her back. The little dashed line you see there is the actual Water beef cow herd rates. Okay, so this was not just a theoretical. The black line is the minimums they were suggesting. The dotted lines is what they were actually achieving at Water. And so I went around to another old set of data. This is from Steve Morris, some of you may know, sitting over there. This is his master's thesis, where he measured suckled Angus breeding cows at 20 to 100 days postpartum, and those are the weights of those cows on 3 blocks, and overall is the average across all of them. So 380 kilos 20 days postpartum, and by 100 days postpartum they'd got back up to 420 kilos. And if you look at a slightly more recent book on energy requirements of animals that was published about 1990, now you see the live weight kilos in relation to the maintenance energy requirements of cows going up to 500 kilos. But that suggests again that the range of weights of these cows was somewhere between 350 and 500 kilos. So about that time there was a really interesting experiment. Well, it wasn't an experiment, it was a commercial activity. It was a bull breeding operation where they selected for net income. So they took the advice that was published in the 1950s by Hazel and Lush from Iowa State about how to select for net income using an economic index, and they selected on an index that had harvest weight, dressing out percent, fertility. So back in 1976 they were selecting these Angus cows for reproductive performance, cow live weight at disposal, and feed intake. So their index included feed intake to try and take account of the fact they wanted to move the cloud in a good, profitable direction. But the phenotypic measurements they used were weaning weight, yearling weight, average lifetime cow body weight, so they were repeatedly measuring the cow weights, and fertility in terms of number of calves weaned. And over 20 years that they ran that program, they lifted weaning weight by 8.6. They lifted milk a little bit, so the cows would have increased their feed requirements due to the milk. Increased post-weaning gain to yearling. Yearling weight went up 14.5 kilos. Harvest weight went up 34 kilos. Cow weight hardly changed. Over 20 years, it only went up by 2.6 kilos. So if they'd kept doing that from 1980 till now 35 years, the cows would be about 5 kilos heavier, right? So I wouldn't have to change that Waterway recommendation for Angus cows very much. And they estimate, it didn't get published this until 2006, but that was worth about $2.5 million based on the 6,500 heifers that went into the commercial program side by these animals. So if you don't recognise it, this was a Lands and Survey breeding operation. So I don't know what cows weigh today, but I don't think they are anything like under 400 kilos post-calving. So when I was sitting up at Massey a week or two ago with Steve Morris, and he looked up these results from the sale here in Fielding on the 5th of May, and there are the weights of mixed age verified in-calf cows sitting around about 600 kilos. Okay. So it looks to me like you've moved the cloud an awful lot. You haven't moved it for harvest weight, but you've moved it an awful lot for cows. Those cows look like they are 150 kilos heavier than they were when I was a student. So that means they've been increasing in weight by about 5 kilos a year. And Temple Grandin, who some of you may know, Temple designed the 5-star feedlot in the South Island. She's designed most of the animal handling facilities at meat plants in the US. She has a saying that people don't notice when slight deteriorations accumulate to become bad things. And one of the recommendations she'd made to companies like McDonald's is you have to actually measure things that matter. And one of the things that have deteriorated gradually is for instance, when they bring chickens in a truck to harvest them and they unload the truck and there's 1 or 2 dead chickens and a few with broken legs. That's normal, right? They've been transported and that's normal that happens. But gradually over time you can get very, very small increases in the number that are dead or with broken legs and nobody notices. It just becomes normal. You get staff coming and going, and if a new staff member comes along and there's a slightly higher rate, they think that's normal. And it's not unless you audit it and put it down on paper that you notice that there's an erosion of these performance measures over time. Now, I would challenge anybody to see that the heifers they'd introduced into their herd are going to be 5 kilos heavier at mature weight and notice that. Probably even if they were weighing them, it would be hard to notice that with all the vagaries of drought and other things going on. Doesn't sound like much, 5 kilos, but over 30 years, that's 150 kilos. So if you want to predict out to 2020, 25, 2030, do you want your cows to be another 100, 150 kilos? Because that's exactly what's going to happen if you keep moving the cloud the way you've been doing it at the moment, right? So if you want to move the cloud in a way to get a lot of improvement rather than a lot of change, you're going to have to start measuring more things that you haven't been doing in the past and using them in indexes, right? If you keep doing what you've been doing before, you're going to get the same result as you were going to get before. That's much, much bigger cows, and if that's what you want, that's fine. That's what happens. So how would I summarise the responses we've seen in New Zealand in various attributes for various things that affect farming operations? So maize, huge changes. When I was a student, the yield you would get on a maize crop would be something like 12 tonnes of dry matter a hectare. And today there are people getting at least twice that. Huge improvements in maize yields in New Zealand, even though we are short degree day, we can only grow short degree day varieties. Pinus radiata, there's been moderate changes and moderate improvements. Particularly you can plant them at lower density and compared to the old days. You had to plant at very, very high density and thin them very heavily. That's not the case now. Broiler chickens, huge changes, huge improvements. Layer hens, huge changes, huge improvements. Pigs, huge changes, huge improvements. They've all been using index selection. They've all been trying to move the cloud in a direction that increases profitability. And when I was a child, you know, chicken was something, unless you grew it yourself, that you had on special occasions like birthdays. And it surprises me when I come to New Zealand now and people are eating chickens every week because they're so cheap, because there's been a lot of genetic improvement, and we haven't seen the same improvement happening in some of the larger livestock like sheep and cattle. Grazed pasture, only small changes. I'd say negligible improvement. The yield of pasture per hectare is really no better now than it was when I was a student. So that's another area where we have to change the way we do selection. We should be producing way more tonnes of dry matter per hectare from ryegrass and white clover now than we did in the past, but we're not at the moment. Dairy cattle, we've seen moderate change and moderate levels of improvement. In sheep, we've seen huge changes, and I'd say moderate improvement. It would have been huge improvement if we'd increased reproductive rate without making the ewes so much bigger. When I was a student, the average ewe was something like 55 kilos, and a 65, 70 kilo ewe was a big one. Now, I know there's an exercise at Riverside where somebody told me one of the ewes there weighs 120 kilos in their commercial flock, right? And beef cattle, there's been huge change. They're hugely different now than what they were before. Is it huge improvement? Well, with my tongue in cheek and being a bit cheeky, I'd say it's been negligible. You've done a whole lot of change in the growth, but you've also done a whole lot on the mature cow side. They've got to be eating a lot more grass at winter time. Now, there's also been a lot of talk in New Zealand, I've heard recently, about resilience and suggestions that our sheep and cattle are not as resilient as they once were, and suggestions that you can't do the kinds of things that the Waterway suggested you should do with sheep and cattle. You can't do those kind of things with our modern animals. I'm not sure if that's true or not, and I can't find any data to back up my suggestion, my cheeky suggestion that there's been negligible improvement, because there has been no data to compare the profitability of a whole farm system. And when I say negligible improvement, I'm talking about where you have a fixed amount of land and you're running a self-replacing herd over the whole lifetime of the herd, accounting for the costs of replacements and so on. Right? And similarly in the pasture, some of you might say, well, you've planted some new pasture and you've got really good response for it. But I'm talking about the response of the pasture over the lifetime of that cycle. So over a 7 to 10 year cycle that you have that new pasture in. Okay, I think that's probably just about enough for me. New Zealand into the future. There's a clear value proposition for selection of beef cattle to improve their profit per unit of pasture consumed. We can move the cloud in a direction to make them more profitable. We know how to do it. And I haven't mentioned genomics, which is one of the big areas that I do a lot of research in, but genomics is just another tool like EBVs and indexes to help us move the cloud. Genetic trends in US beef breeds do not appear to me to be offering these benefits, even in the US circumstances with increasing harvest weights. Genetic improvements in profitability will not be achieved by selection on growth traits alone. They're going to require you to have information on the whole range of traits that influence income and expenses. Okay? New devices, RFID scales and so on, can assist in measuring additional phenotypings. New technologies, DNA sequencing, genomics, marker panels, gene editing, gene drives, they provide new approaches to improvement, and we're only just starting to look at ways that we can use those. It's been several years it's been available, but of course it's easiest to use those technologies to improve growth, because growth is what we have a lot of data for. But it's not growth that we want to improve at a faster rate, it's we want to move that cloud towards profitability, which means we want to move it based on things like the feed requirements of the cow or the mature size of the cow or the facial eczema resistance of the cows and the sheep. The value proposition does not allow bull breeders to recoup investments in these approaches. So in the industries like chickens and pigs, the value proposition is very, very good, and maize, for the breeding companies to capture any extra investment. It's much more difficult for it to be done in the bull breeding sector. And I've had a number of beef breeders in the US tell me, for instance, that they are interested in putting in, say, a grow-safe system so they can measure the feed intake of their cows. But the dilemma they have, if they invest in a grow-safe system and the data goes to the breed association, the breed association can use it to get genomic predictions of feed efficiency, and all of their competitors who are not putting in grow-safe systems get better EBVs based on genomic prediction, which erodes the value proposition of them putting in the grow-safe system. So if you did a whole system analysis of the country, you might say that measuring feed intake is a useful thing to do, but for an individual breeder investing hundreds of thousands to put in that system, they're probably not going to get hundreds of thousands of dollars worth of reward. A lot of that reward is going to be spread to their competitors who use the same size they do and get the same predictions from their data. So what that means is that adoption of these new technologies really requires collaborative funding to fix that market failure. And the best way for that funding to come about, if you're not vertically integrated, is for it to come from levy funds on each animal that gets harvested, like has Beef and Lamb New Zealand collects and passes some of it on to Beef and Lamb Genetics. That sort of funding should be subsidising, which is a bad word to use in New Zealand, but it should be subsidising the investment that happens at the seed stock or nucleus sector, just in the same way that other organisations like dairying have been enjoying. So genetic change, easy. Genetic improvement, much more challenging to achieve. Improving the profitability of beef cattle for New Zealand sheep and beef farm circumstances as a result of selection will require new approaches, particularly to the traits that we measured, not simply doing more of the same that you've been doing for the last 30 years since I've been a student, because I can already predict what the outcome of that will be. Okay. What I would really like to see is, if I get to be here 30 years from now, is a little bit of an inflection when I see those graphs of the EBVs over time. So thanks very much. I think it's time now to have some questions.
Yeah, Dorian, I don't disagree with your overall message, but probably when you were a student, and even when I was one, once a long time ago, the steers and the heifers that were being turned off were older. You know, they were 3 and 4 years old typically.
Yep.
And the market signals in New Zealand has really been to retain a 300 kilogram carcass,
Right.
because of the cut size.
Yeah.
But I would suggest they are going off a lot earlier now.
Yeah, I suspect you're right, Tim, but I just can't find any data on that. And when you go back and try and search for this information, you know, there's internet data sort of from 2000 onwards, and there's nothing much before that. And because there's been virtually no beef cattle research or beef genetics research the last 20 years or so, there's not data to demonstrate that. But I suspect you're right, that it may well be that many of those 300 kilo animals are being killed after one winter rather than after two, as occurred in the past, but that data's not around. So that would indicate that you know, maybe the cost of those cows being 100, 150 kilos heavier is partly being compensated for those steers being killed earlier. But I would argue that they would have been even more profitable if those cows could have been another 50 kilos lighter. And we saw from that Landcorp experiment that you could actually end up with heavier harvest rates and have no difference in cow size. But in order to do it, you had to measure cow size and you had to select on an index that took account of the feed costs of bigger cows.
Dorian, since you're a student, we've seen the development. Dorian, since you're a student, we've seen the development of NATE. Should we as an industry be using that database to greater value?
Yeah, absolutely. The individual identification can be helpful. It's not easy. Presumably what you're talking about, John, is collecting data on more commercial animals rather than on just the pedigree registered animals. And yes, that is a good idea. The dairy industry has been taking advantage of that for years. You know, all their herd test records come from commercial herds, not from the bulls themselves that are used for AI. It is a little bit problematic in practice to use that data. Partly because you don't have the sire information on many of them, but also because the contemporary groups get split up. So in order to tell who is a good animal, as you would know, we need to know the phenotype relative to other animals that were treated the same. And when animals get killed by a farmer because they are finished and ready to be killed, they don't kill the whole crop. You know, the best data we could get in a progeny test for carcass information, we take a whole cohort of steers and we kill them all on the same day. And that's not what happens in practice. People kill them when they are at their optimal value. And the carcass data we see in the US, for instance, has almost no value for discriminating differences in fat depth, because they're almost all killed at about the same fat depth. So we get good discrimination for other things like carcass weight. So not all of the commercial data will be valuable, but for those cohorts that stay together and get harvested as a lot, that would certainly be valuable information. And it might also be valuable for some of these other traits like facial eczema, if we could look at the livers and get liver damage scores, doing that on large numbers of commercial animals that we can't easily do in a registered herd. That would add value. So it doesn't make any sense to me to put an air tag in with a number and then not use the data.
Dorian? Dorian, did I hear correctly that steers from high milk lines eat more feed simply because they're from high milk lines as opposed to low milk lines?
Yeah, that's correct, and this has been known for a long time. If you look at the feed requirements for animals, the published tables that show you how to calculate them, they'll tell you that the EBV for milk production is part of the determinant of the maintenance energy cost. And I showed you data here from Hereford and Angus. What I didn't show you in the US was data from Red Angus. Red Angus was one of the most progressive breed associations in the US. It was the first one to push for total herd reporting, for measuring heifer pregnancy and stayability and so on. And one of the EPDs they produced was a maintenance energy EPD. So they actually have a EPD for maintenance energy, and that calculation is done based on the mature weight of the cow adjusted to a constant condition score, and then there is another adjustment for the milk production EPD of the animal. There was a lot of data out of Ireland, out of the Grange research station there, showing, I think it was Charolais cattle of steers that were fed with different milk production potential, showing their maintenance requirements changed. The probably obvious place that you might have seen it in New Zealand is if you'd had, say, Hereford Friesian steers running with Angus steers on the hills, and you got a bit short of feed, you'd see them struggling a little bit more before the traditional British breeds would have.
Yes, Dorian, I was very interested in your comments regarding some of the data that does come out of America, because a lot of us feel that it's difficult to interpret some of that data to the New Zealand conditions, but often feel that they concentrate on those growth figures and we don't get the data to see what's happened to their reproduction traits.
Right.
And I just wondered where in Ireland, where you tell us that they have got a lot better recording systems. I have heard that they've chased growth in Ireland pretty much the same as America, but they do have reproduction graphs in Ireland. So can you tell me what they look like?
Yeah, sure. So a good point. So I said, Ireland probably has one of the best practice recording programs for livestock. They've got a single database that does all their dairy cattle, beef cattle, sheep, commercial farms, collects Carcass data and so on. But they have also had a disaster in terms of improvement of their suckler cow herd. And the first time I went to Ireland, they were mostly Angus and Hereford animals and some shorthorns. But when they introduced the EU ROP classification system based on conformation, the Limousin sired animals in particular did much better on that grading scheme. And many of the herds are only 10 or 20 cows. So if you've got 10 or 20 cows and you have a Limousin bull to produce carcasses that better meet that grading system, and you need one female replacement, you keep that Limousin cross female. So now when you look at the Irish suckler cow herd, it's largely crossbred, largely continental crosses. The cow weight is something like 700 kilos. Most of them don't calve until they are 3. They have very, very poor reproductive performance, and they have invested a huge effort. The funding has been brought in to try and improve their operation, and they have a plan to collect over 1 million genotypes on their commercial suckler cow herd, not their registered herds, their suckler cow herds, all of them, using their equivalent of their NAIT. And they haven't quite got to the 1 million. They've shared the data with me. I think there's about 520,000 so far that have been genotyped, and they'll be doing another 500,000 over the next year or two. So they have got good practice data recording, but it takes more to move the cloud than just having a good recording system. You also have to have people making sensible selection decisions, and sensible from a point of view of genetic improvement. And what's made sense to a small operator with only one bull and a few cows is to keep that daughter, and that's caused the erosion in their performance. It would be much better if they could have accessed a smaller maternal line, and a far better efficient productive system for them would have been had different maternal lines to be the mother cows, or suckler cows as they call them, and used a different kind of animal to be the terminal sire line. The problem they have made is they are using terminal sire breeds and terminal sire bulls to produce daughters, and that's gone on for 20 years. And I think it's probably a bit of what's happened in New Zealand. That's why our Angus cows are so much heavier, for the same reason. People have used animals which, to me, would have been more suited to be terminal sires as the fathers of daughters. A better breeding program, if you want to use those kind of sires, is to have sires that are deliberately bred to be maternal sires. They're bred to produce daughters, and you would have some of the national herd mated to bulls to produce daughters, and you'd have the rest of the herd mated to terminal sires. Now, it's not easy to make those things operate in practice, but that would be much more efficient and profitable.
Dorian, a question here. Just when we think about moving the cloud, so it's a new term we've all learned today, so thank you. But we think about some of the things that we will need in the future, some of the things we need to incorporate in the cloud, and you referenced facial eczema. Our cows need to be better, not bigger. And there are a bunch of other things in there, like more environmental cows, things like that. How our resources are limited, so how are we going to do that so often when our resources are defined, also our decision making is defined by the coat colour of our cattle?
Yeah. I mean, when you talk about resources, I mean, there are two things that come to mind to me, and one is the genomic resource, which is the number of animals you have to breed bulls, say. And I think that is more than adequate. If you look at the genomic resource that's used in chickens or pigs internationally to produce the layers and broilers that are consumed in New Zealand, their breeding programs are a fraction of the size of the collective beef breeding programs generating bulls in New Zealand. A typical selection line in layers is something like 1,000 females, right? you've got something like 30,000 performance recorded females in New Zealand across the breeds. So there's plenty of resource in terms of genome here to move the cloud without having to rely on people in other countries. I showed you the low-line data where, just under 100 cows was enough to generate a breed that's become very distinctive. So I don't think there's a genomic resourcing problem. The problem is more of the market failure and getting enough cash to be able to measure the things that need to be measured on that genomic resource. And, we know that market failure is a big problem in this area, and it relies on some sort of subsidised way from the people who benefit from those improved animals. And again, I think it's the levy thing that matters. The other thing you mentioned was the coat colour thing, and yes, the US have changed virtually all of their breeds to be black. There are black Limousin crosses. There's black black Geltby crosses and Simmental crosses, and there's even black Herefords. So if anybody was to do an analysis, the cost of changing the US national herd to black would have been millions and millions of dollars of lost opportunity for moving the cloud in a profitable direction. But it was just driven by the CAB requirement that the animals had to be 50% black. So